During the course of this video, we'll take a closer look at some unique tools from the Robert Sorby range of specialist products. The Robert Sorby 200 KT, or multi-tip hollowing tool, is one of the safest and most flexible multiple-use tools available today. By fitting interchangeable cutting tips, the tool can be used as a standard scraper for both internal and external work, as a shear scraper, and as a superb hollowing system. 3 cutters are supplied with the tool initially. There are also a range of additional cutters that are available as optional extras. The first one we'll have a look at is this multi-faced scraper blade. This can be fixed onto the tool shaft to provide a half round, square or shallow curve scraper. For use as a traditional scraper, use the tool with the large flat section of the blade facing down onto the tool rest. The tool rest is placed higher than centre and the tool trailed down to cut on to centre height. This combination provides a large support area whilst only a small section of the tip is cutting. This improves stability and control. This style of scraping can be utilised with both end grain projects and cross grain or bowl work. One drawback with standard scraping is that with softer woods, areas of grain can be caused to lift up or rip, leading to a poor quality finish. This can be minimised by using the tool in a slightly different manner to produce shear scraping. Shear scraping is created by holding the tool so that the cutting edge is presented to the work at an angle. 45 degrees would be a sensible starting point, and we've marked the centre line of the wood and a suggested line to hold the cutting tip against. Later we'll see that this angle can be altered to allow the tool to take a heavier or finer cut. By shear cutting, the fibres of the wood are being peeled away rather than being ripped out. The cutter blade has a 90-degree bevel on its front edge, and by rubbing this against the work we can increase the surface finish by allowing the bevel to support the cutting point and burnish the wood. This type of scraping is almost always used as a finishing technique rather than as a method of bulk waste removal. By altering this angle, turning the tip out clockwise beyond 45 degrees, we allow a greater area of the cutting edge to come into contact with the work. This produces a heavier cut, but if too heavy a cut is taken, it can lead to vibration and chattering, as we can hear now. The more the piece is extended away from the headstock of the lathe and the thinner the section of work, the more likely this is to happen. These shavings are the result of these heavier cuts. Conversely, by backing the tool off, turning the tool anti-clockwise to reduce the amount of cutter used, we can create a finer cut with the tool now presented at an angle much less than 45 degrees. By using less of the cutter, the shavings produced now are much finer. This pole has some ridging and tool marks that shear scraping can quickly improve. On the exterior of this bowl we would use the flat or square face of the blade. Several passes may be needed to remove any tool marks, but this shows that the finish created by shear scraping can be worth the effort. For the interior, we have marked in pencil the centre line of the wood and the centre line of the tool. This allows us to see that the tool is used with the rest set to a height that allows the centre of the tool to cut onto the centre line of the work. Once again, we may need to take more than one pass and can adjust the cutter angle to provide a heavier or lighter finishing cut. Before moving on to the hollowing cutters supplied with this tool, let's have a look at one easy method of sharpening this scraper blade. If the cutter is in reasonable condition, it can be topped up by using a diamond file to hone across the cutter face. This is a medium or 40 micron diamond file and is being used with water as a lubricant. By exchanging the cutting tip and fitting this round-ended hollowing cutter, we have completely changed what the tool can do. It now becomes a safe, stable hollowing tool capable of working end and cross grain. Starting with the cutter facing forwards, we again make use of the flat section of the tool shaft onto the rest. Once again, this combination of large support area and small cutting tip makes the tool easy and safe to use. We set the tool rest back slightly so there is no danger of the clamp assembly that holds the cutting tip becoming trapped between the rest and the spinning work. With the tool held horizontally and cutting onto the marked centre height, the tool effortlessly opens up this end grain box lid and is capable of quickly removing waste material. Taking heavy cuts wouldn't always give the highest quality finish though, and so finer, glancing cuts are taken towards the end of a project to increase the quality of surface finish. As the depth of hollowing increases, the tool rest is brought forwards towards the work to minimise the tool overhang and increase its support. Having seen the tool work well on an end grain project, let's now look at the tool in use with a small hollow form. We already have a starter hole here left over from the screw chuck mounting, and this makes an ideal point to commence working out from. With the cutter tip facing forward, however, there will come a point whereby undercutting becomes difficult. A major advantage of this tool is that the cutting tips are designed to be able to swivel. Limit the swing so that the whole of the cutter remains within the supported area initially, although with experience this can be taken further if desired. Even with a modest amount of swivel, the tool can perform quite severe undercutting. In this partially completed example, right back to 90 degrees from the entrance hole. A third cutter tip supplied is similar to the round-ended hollowing tip, but has two flats ground onto the end at a combination angle of slightly less than 90 degrees. This cutter provides a solution for the times when a clean, crisp 90-degree corner is needed, rather than the gentle round created by the first tip we examined. To sharpen these hollowing cutters, once again the diamond file quickly restores and maintains the cutting faces. Everything we've looked at so far is supplied as standard with this tool. To increase the versatility of this tool even further, additional cutters can be purchased to use with this tool. These include matched sets of beading and cove cutters and a recess cutter blade. One matched set offers size options of 3/8 and 5/8 inch, whilst the second set allows a 1/4 and a 1/2 inch. These are also available individually. These are used in a scraping action, raising the tool rest to allow the tip to trail down onto the centre line. Moving the tool gently from side to side allows the waste material to be removed and the central bead or cove quickly forms. To highlight this bead, we have removed the waste wood from either side, bringing the bead into relief. Whenever accuracy and repeatability are an issue, these additional cutters can be invaluable. Lastly, we have the recess cutter that is used in a similar manner to trim and create dovetail recesses used by today's popular chucking systems. Once the advantages of shear scraping have been explored, many wood turners increasingly incorporate it into their work. Many of the advantages of the triple-faced scraper blade supplied with the 200 KT tool are available in the more compact 868H micro shear scraper. The round shank of this tool enables it to be rotated to produce differing degrees of cut, and makes a handy dedicated shear scraper for both external work using the flat square face of the blade or for internal shear scraping using the round faces. One particular benefit this tool has is its ability to work well within the confines of a smaller, restricted size work area, such as the inside of a small goblet, bowl or egg cup. Taking over where the 200 KT leaves off, the RS230 Hollow Master tool offers increased capacity and extended reach, but retains many of the key features and advantages of its smaller brother. When might the 200kT not be the obvious choice of hollowing tool? One consideration would be the depth of the project being undertaken. The maximum working depth of the 200kT is approximately 6 inches, but there may well be times, like for instance with this end grain vessel, that the depth to be hollowed out is greater than the maximum the 200kT can offer. The 230 Hollowmaster offers increased depth and remains stable in use due to having retained the substantial shaft and large support area from the 200kT. This tool also features a swan neck curve to the end of the shaft, allowing a greater degree of undercutting to be taken whilst working through a restrictive size of opening. If the curved section of the tool is placed onto the rest, the force exerted by the spinning timber could cause the tool to twist, making any degree of control difficult if not impossible. As with all swan neck or cranked tools, the tool rest is moved back away from the work to allow the tool to be supported along any point of the straight section of the shaft. This places the cutting tip back in line with the support point and control and stability are restored. After using the round hollowing tip to complete the majority of hollowing, the round shear scrape blade can be fitted to produce a good quality surface finish. As it is not possible to show the effect of this tool inside a deep hollowed vessel, we have fitted the blade and will take a finishing cut on the inside of this maple bowl. Again, the tool rest is placed against the straight section of the shaft and the cutter placed onto the centre line of the work. In recent years, one area that has grown in popularity is the patterning and texturing of wood-turned work. Robert Sorby were involved in co-developing one of the first commercially available tools dedicated to patterning and texturing. This flexible and versatile tool can be used to create a wide range of patterns and texture effects on both spindle and bowl work. This tool is supplied with a texturing cutter. This comprises a wheel, accurately made from top quality tool steel, which has a bearing recessed into its centre. This means that the wheel, once placed against the rotating work, is free to spin. By altering the angle that the tool is held at, a wide range of different effects can be created. Here the cutter is being held with the teeth of the wheel vertical to the rotating work. The tool rest is just below the centre height of the work, allowing us to trail the tool slightly downwards to provide a safe method of working. We are holding the cutter vertically, and by moving the tool from side to side, create a stipple or orange peel effect. On this occasion, the tool is held with a small degree of tilt to the cutter, so it is held at around a 20-degree angle. This degree of tilt is not critical, but the more the tool is opened out, the heavier and more aggressive the cut becomes, and this is worth bearing in mind if using a softer species of wood. As well as creating a wide range of textures to the exterior of bowl work, the tool can be used to enhance platters, either by texturing the rim or by creating a rosette feature in the centre. A micro skew chisel is used to create V-cuts to define the start and end of the texture area. This tool can be expanded by purchasing optional cutters that can be added on to this tool. Whilst these cutters are also used for spiralling work, which we'll be looking at a little later, they all work well as texturing cutters. With each additional cutter, the size of the cutting tip and the space between them varies. This can be a useful tool to augment end grain work, and in many instances can offer an alternative choice to a chatter tool. All of these effects were created using the texturing tool and just 2 optional cutters. As with the chatter tool, consider altering the wood around the textured area to create a highlight area. Consider making use of stains and coloured waxes to further enhance work. This tool was developed as a progression from the texturing tool we looked at earlier. Compared to the basic texturing tool, when we incorporate spiralling into our work, the tool is changed in 2 ways. Firstly, it would be impossible to hold the tool freehand and guarantee holding the tool at the same angle all the time. To overcome this, the tool is fitted with a cradle. The cradle allows the tool to be adjusted and locked into one fixed position. By placing this cradle onto the tool rest, the increased surface area means the tool is better supported and the angle of the cutting wheel to the work is kept constant. The shaft of the tool has been etched with a centrally located reference line. A series of numbered indexing marks are placed around the bridge of the cradle. By lining up the reference mark against the indexing scale, popular combinations of spiral pitch and size can easily be repeated. The second change to the tool is the change of cutter wheel. Spiralling cutters have a flat face to the edge of the wheel. We can make use of this almost as a bevel to rub against the wood, allowing a smooth and controlled start to a spiral. All of the cutters benefit from being kept in good condition and work best with a clean, sharp edge right on the corner of the flat and angled faces. This is the section of the wheel that actually does the work. Sharpening is best achieved using a small diamond file or sharpening stone. Hold the file so that the cutting face of the file is sitting onto the angled or beveled top face of the cutter wheel. By rotating the wheel by hand, the cutting edge is maintained with minimal wear to either the cutter or the file. An alternate method of sharpening involves raising the tool rest and trailing the wheel vertically down onto a piece of scrap wood that is rotating in the lathe at a low speed, about 400 to 500 rpm. The diamond file is then brought into contact with the beveled edge of the wheel. The 330H kit comprises the tool shaft and handle, the texturing cutter we were using earlier, and 3 sizes of spiralling cutters. These are referred to as being 2, 4 and 6 mm. This simply denotes the size of the spacing between the teeth on the wheel in millimetres. This shot also shows 2 additional cutters that are available as optional extras. For anyone using the tool for the first time, the following example would be an ideal introduction. There are 3 washers that are fitted around the bearing in the centre of the wheel. This bearing is recessed down, and so 2 washers are fitted into the top of the cutter and 1 below. Once in place on the tool shaft, These are held in place by the Allen head bolt. After tightening the bolt down, the cutter wheel should still be free to rotate. In use, the principle is the same for all the wheels, but the 2mm wheel removes far less material and so is faster to use. The spiral it produces is quite fine and delicate, so a fine-grained hardwood would be best. Please note that not all timber will be able to support a spiral this fine, so the general rule of thumb is that as the wood becomes softer, so the size of cutter wheel being used needs to increase. Let's set the cradle up so that the wheel is tilted to one side, but not by too large an amount to begin with. Whilst we are getting used to the tool, a less steep pitch, with the tool offset only by a half to one full graduation, will offer less resistance and cut more easily. Having turned the work down to round, reduce the lathe speed to around 500 rpm. This figure isn't set in stone, however, and 100 or 200 rpm either side of this will not stop the tool from working. Set the tool rest so that with the tool placed horizontally, the cutting wheel is resting just above centre line height, marked on this piece with a pencil line. The tool is used by raising the handle to allow the teeth of the wheel to contact the revolving work at centre line height. To begin cutting a spiral, the tool is placed onto the tool rest, ensuring that the full flat of the cradle rest is sitting on the tool rest. Cutting starts as the tips of the teeth contact the wood at centre height. Hold the tool steady in this one position so that we can create a reference groove or a starting point that we can locate the tool back into. Withdraw the tool and stop the lathe in order to check that we have a clean starting point. The tool can then be relocated back into this groove and the spiral extended. Lift the handle again until the cutting point is felt, and then move the tool steadily along the wood. Whilst with practice it's perfectly possible to do this in one smooth motion, if too much pressure is applied or the tool moved too quickly, the cutter wheel can be caused to jump out of the groove. Here is an alternate method of creating the first full spiral groove. Start the groove exactly the same as before. Now move the tool handle slightly to one side. Whilst holding the cutter wheel in the starter groove, swing the handle back to a central position, moving the wheel slightly further along the workpiece. By repeating this action a number of times, the groove is extended slowly but surely. This groove will not be to the full depth of the cutter, and it will be necessary to run the tool across the groove several times more until the full depth of the spiral is created. By angling the cutter wheel to the left and the right of the centre point, spirals can be created that slope in opposite directions. With a close-grained hardwood, they can even be superimposed one over the other. The Robert Sorby RS215 KT Chatter tool is used to produce unique patterns and decoration on end grain work. The tool comprises a handle, shaft and a clamp assembly into which two double-ended cutters can be fixed. The first of these has a bead or rounded over end, and the opposite end has a cove shape. The second cutter has one face flat and one with a V point. The kit also includes a multi-face scraper blade. The cutters are stamped from a special grade of spring steel to allow them to flex in use, and there is no burr present on these cutters initially. This burr is important as it is the burr hooking into the wood that causes the tool to chatter and create the pattern. The burr can be formed in several different ways. Using a diamond file will produce a fine burr on the cutter. Touching lightly against a bench grinder wheel will produce a heavier burr. If doing this with the cutter held in the tool, ensure that the cutter blade is withdrawn up into the clamp to allow only a small protrusion over the edge. This will ensure that the blade does not chatter as it is applied to the spinning wheel. The only exception to this is the cove-shaped cutter. This is best sharpened using a half-round diamond file or slipstone, as it is not possible to sharpen this shape with a flat grinding wheel. With a piece of end-grain timber prepared and mounted in the lathe, let's have a look at the tool in use. There are many different patterns and effects that can be produced with a chatter tool, so we can only hope to cover the basics here. The first thing that will have an effect on the pattern produced is the amount of the cutter that is allowed to protrude beyond the end of the clamp. The greater the amount of overhang, the more the tool can flex, and this will result in a heavier, more spacious pattern. Reducing the amount of overhang will minimise the amount the cutter can flex by and would normally produce a tighter, more closely spaced pattern. As a starting point, I would suggest having about 1 inch of the cutter extended. Naturally, wood can vary in density, and this can be exploited by deliberately choosing a close-grained hardwood if a very fine, delicate pattern is wanted. For most chatter tool work such as goblet bases, coasters, box lids and such like, around 1000 RPM would be a safe starting point. To begin with, it is easier to work with the tool trailing down slightly, with the burr edge of the scraper cutting on to centre height. Think of the tool as working just like a scraper. They are often used with a handle raised slightly, dropping down onto centre. Be aware that when this tool is working well, it leaves you in no doubt. The tool produces a high-pitched screeching sound when in use. Once the note reaches its highest pitch, this tells us that the maximum amount of chatter for that particular combination of wood, speed and tool cutter protrusion has been achieved. By altering the amount of cutter that is allowed to protrude, we can change the pattern. Increasing the length of the cutter allows the tool to flex to a larger amount and produces a slightly heavier pattern. Only having a small amount extended will produce a much finer, closer spaced pattern. Another method of changing the appearance is to alter the height that the cutting edge is presented to the work at. When working directly onto centre height, as we have done so far, the pattern formed will appear to run out radially from the centre. By working with the cutter either above or below centre height, the pattern changes and now seems to run out from the centre at an angle. By alternating the height, a herringbone type effect can be produced. Each cutter has the option of 2 different shaped cutter tips. The pointed cutter can be used to chatter into a V-cut, or can be used on its side using 1/2 of the cutting edge. The other cutters produce a decorated cove or a bead. With the bead forming tip, it can be an advantage to place a small groove at the start point of where the chatter tool will be. By placing one of the outer points of the tip into this groove and pivoting the tool around, the chances of the tool wanting to skip or skate over the surface of the wood is minimised. Experiment by using different techniques to refine and highlight an area of chatterwork. In this example, wood is being removed from both the inner and outer edges of the chatter tool work band to help define and attract attention. The contrast between the plain wood and the chatter work is enhanced, and it allows a chance to create very crisp, define stop and start points for the patterned area. The shadow line created by raising up the pattern band also helps to draw attention and create interest. As another option, why not consider creating a small band of chatter work and then part it away to produce a small patterned insert? This could then be inlaid easily into a contrasting wood. Finally, in addition to the versatile chatter cutters, this tool is supplied with a multi-face scraper blade, ideal for shear scraping smaller items. Many of the specialist tools that Robert Sorby produce make use of interchangeable tips and cutters. These can be replaced when necessary, and with many tools, optional items can be added to expand the range and capability. As the name suggests, this is an exceptional spindle turning tool capable of cutting coves, beads, planing and trimming end grain. The tool is available with blade sizes of 1 inch, 3/4 and 1/2 inch wide. There is also a compact micro version of this tool available. As this close-up shot of the cutting tip shows, these tools are flat on the top face of the tool and have a shallow curve section to the underside of the tool. The cutting tip is ground to a fingernail style shape with the bevel on the rear of the tool very highly polished. This polished bevel is important and contributes to the quality of finish that this tool achieves. We'll run through a number of basic cuts using a spindle master and have mounted a length of square section pine into the lathe. The tool rest height has been set to just below centre, although some users prefer to set the tool rest a little higher as if using a skew chisel. By all means try more than one height for the tool rest and see which you prefer. When cutting with the spindle master, it is important not to start a cut with the very tip of the tool. Allowing the tip of the tool to contact with wood at the start of the cut would allow the cutting edge to cut with none of the bevel supporting or controlling the depth of cut. This would make the tool almost impossible to control. Most cuts are started using the side of the tool. If in clock face terms the very tip of the tool is 12 o'clock, the safe cutting areas would be from 1 o'clock to 3 o'clock and from 11 o'clock to 9 o'clock. In this sequence we use the tool to cut across end grain, taking a series of light cuts to round over one end of this square stock. As we come towards the end of the curve, the top point of the tool can safely be used as it is now supported by the bevel rubbing against the work. The quality of the finish is exceptional and often needs little or no sanding. Used in a similar manner to a skew chisel, here the tool is producing a planing cut, taking several light cuts with the bevel of the tool rubbing to provide support for the cutting tip and producing a burnishing effect behind the cut. As these close-ups clearly show, there is no evidence of any rip or torn grain. Moving on to an OG shape, where a cove and bead are combined into one flowing shape, The tool is opened up slightly once the cut starts, to cut the cove section, and is then rotated around and the handle lifted slightly to create the bead. Once again, the quality of the finish straight from the tool speaks for itself. The spindle master can also be used for cutting V-cuts or creating pommels where square stock is cut down to round, as often seen in furniture components. The method is again many light cuts, this time alternating from the left and right hand sides. Notice at the end of this cut, the tool is lifted slightly to allow the tip of the tool to create a clean, sharp intersection at the centre of the V. Sharpening is quick and easy. Simply hone across the flat face of the tool with a diamond file or sharpening stone. Here we are using a medium grit or 40 micron diamond file lubricated with water. A recently developed tool from Robert Sorby is the Sandmaster. This system provides a safe and effective method of finishing most items of lathe-turned work. A 2-inch diameter sponge head is fitted with a Velcro pad that is used in conjunction with cloth-backed abrasive discs. This head is fitted into an adjustable knuckle joint. Phosphor bronze bushers allow this head to spin freely when placed against rotating work. By releasing the locking mechanism, the head is free to be rotated over a wide range of movement and can be locked into the most suitable position for use, dependent upon the size and shape of the item being sanded. There are a range of different grit sizes available for use with this tool, and it is supplied with aluminium oxide sanding discs in grits of 60, 120, 180, 240 and 400. As an optional extra, when working with larger projects, it is possible to remove the 2-inch diameter head and replace it with a larger 3-inch version. Although not a part of the basic system, the Sandmaster can be further developed by adding an optional pigtail mandrel and shaped goblet or bowl mops of varying sizes. This allows the tool to be used for burnishing oil or wax finishes onto work. Occasionally, it can be beneficial to lubricate the tool with a drop of lightweight oil onto the bushings. Take care to ensure that any excess oil is removed with a tissue or cloth prior to use. Sanding using the tool is carried out on the lower half of the workpiece so that the wood is turning away from you. As sanding is capable of producing fine wood dust, all sensible precautions should be taken to ensure personal safety. Here we are using both a powerful workshop extractor as well as a filtered dust mask. In use, the tool is placed against the rotating work with the face of the head opened out slightly so that the wood contacts the lower portion of the disc. The abrasive and wood together provide the friction that drives the sanding head. This means that the head will rotate faster at the edge of a workpiece and more slowly towards the centre. Lathe speed is not critical and should always be appropriate to the size of the item being worked. In most cases, a speed well below 1000 RPM will provide good results and will minimise heat build-up. This is a particularly safe method of sanding as it removes the need to put fingers anywhere near rotating work. Changing the disc is done by holding the head securely and peeling the cloth-backed disc from the Velcro pad. It takes literally seconds to remove one disc and replace with the next finer grit. Normally, all the discs would be used in sequence to produce a final finish. As the intermediate sanding with each grit is identical, we have moved on slightly and have just finished using the finest abrasive disc, 400 grit. A gallery quality finish is quickly and painlessly achieved. If considering oil or wax as a final finish for a piece, the Sandmaster system can be modified to produce a buffing tool. After applying the finish manually, by fitting a pigtail mandrel and bowl mop, the tool can now be used to burnish oil or wax into a finished piece of work. In the case of an oil finish, this produces a satin sheen. This second platter, also sanded and finished with a Sandmaster, had a paste wax applied on top of several coats of oil and has buffed to a very high gloss. In this section, we're going to have a look at both the replacement tips and optional items that are available for all the tools we have featured during this video. The RS412 is the 2-inch diameter Velcro sponge head that is supplied with the Sandmaster tool as standard. If you regularly undertake larger size projects, the RS413 offers the same style of head but with a larger 3-inch diameter. Replacement packs of abrasive discs are available in a range of grit options. 2-inch diameter discs have the product code RS412A, A for abrasive, followed by the grit size 60, 120, 180, 240 or 400. These discs are also available for the larger 413 3-inch diameter head, and the reference number then becomes RS413A, again followed by the grit size. To convert the Sandmaster into a polishing and buffing tool, the RS491 pigtail mandrel is available. This is then used in conjunction with the goblet and bowl mops that are available as follows. RS492, a 2-inch goblet mop. RS493, a general purpose 3-inch bowl mop. And RS494, the largest bowl mop with a 4-inch diameter. Three cutter tips are supplied with the RS200KT. The RS211C is the round-ended swivel tip cutter used for the majority of hollowing and undercutting work. The RS212C is also supplied as standard. This is the side and end cutting tip used to create a 90-degree corner. The last of the three standard tips is the RS200C, a medium teardrop blade used for both normal and shear scraping operations. The following are optional cutters that are designed to be used with the RS200KT tool. RS239C is a bead cutting tip that will quickly and accurately form 1/4 and 1/2 inch beads. The RS236C is the same style of cutter, but this time produces beads of 3/8 and 5/8 in size. There are also cove cutting tips available that are designed to match the bead cutters. The first of these produces coves of 1/4 and 1/2 inch size. This is the RS238C. The RS235C produces coves of 3/8 and 5/8 inch size. For undercutting recesses at 45 and 60 degree angles, the RS234C completes the optional cutters currently available for use with this tool. The RS222 is the compact size teardrop cutter supplied as standard with the 868H tool. This tool has two standard cutters, the RS211C, the round-ended swivel tip cutter that is also a standard tip with the 200 kT tool, and the RS230C full round shear scraping cutter. Supplied as standard with this tool is the RS350/0 texturing cutter. All of the spiralling wheel cutters that feature with the 330H tool can be used to create texture effects. While some of these are supplied with the 330H system, they are all available as optional cutters for a 310H texturing tool. These include the RS350/2 with a fine 2mm pitch, the RS350/4, RS350/6, RS350/5 with a V rather than a U-shape profile, and the RS350/11. The tool can be further expanded by adding an RS360 cradle assembly. This effectively converts a texturing tool into the 330H spiraling tool. This system comes complete with cutter wheels RS350/0, the texturing cutter wheel, and spiraling cutter wheels RS350/2 with a 2mm pitch, RS350/4 with a larger 4mm pitch, and the 6mm pitch RS350/6. The RS360 cradle is also included as standard. Two further wheels are available as optional extras. The RS350/5, a 5mm pitch wheel with a V-tooth profile, and the largest of the available spiraling cutter wheels, 350/11. Two double-ended cutting tips are supplied with this tool. The RS220 has both square and pointed ends, and the RS221 offers domed and hollow options. The medium teardrop cutter RS222 converts the tool into a superb shear scraper. For use with many of these tips, where sharpening on a bench grinder would be too aggressive and wasteful, the RS224 diamond file provides a fast and easy method of maintaining the cutting edge.